Hello dear students, welcome to ECE Academy Benefactor. The topic of the class is Priority Encoder. This topic is from the combinational logic circuit and the subject name is Digital Electronics. In this class we will be seeing the definition of priority encoder and then we will see the design steps of logic diagram of a priority encoder. So, we know how to design a combinational logic circuit. First, truth table, second step is K-map simplification and third step is drawing the logic diagram. So, let us start with the definition of a priority encoder. A priority encoder is an encoder. What is an encoder doing? Encoder is converting from one code to another code. It is having 2 to the power of n inputs and n output lines. A priority encoder is an encoder circuit that includes the priority function. Suppose if you are transmitting number of bits, so priority encoder will set the priority of each bit, which data bit is having higher priority. When it appears, it has to give in the access and has to appear at the output. A priority encoder is an encoder circuit that includes the priority function. In priority encoder, if 2 or more inputs are equal to 1 at the same time, the input having the highest priority will take the precedence. Means if after setting the priority of the data bits, if 2 or more bits are set to 1, so the data bit having the higher priority, the output will set according to that highest priority bit. So, a priority encoder is an encoder circuit that includes the priority function. Let us start with the truth table of the priority encoder. Here we are having the truth table having inputs and outputs. Inputs are 4, D0, D1, D2, D3. Outputs are Y1, Y0 and V is the valid output. This valid output indicates that this valid V is equal to 1. It means that at least one of the input is high. If all the inputs are zeros, it will be set to 0. If any one of the input is 1, if at least one of the input is 1, it will set into 1. That is written. So, this valid column, valid output column is when all the inputs are 0, it is also 0. If at least one input is high, it will be set to 1. So, here all the inputs are 0. So, it is set to 0, valid output is set to 0. When all the inputs are 0, when no input is coming, what is output? We do not know, it is a 0 because this what happened? Valid output is 0, so they do not care. Next step, if here there is a setting of this, there are 4 bits. So, D3 bit is giving the highest priority and then is given to D2, then next priority is D1 and the least priority is D0. Highest priority is of D3, lowest priority is of D0. Now, let us see the condition 1, D0 is 1 and all other inputs are 0. D0 is 1 means what will be the output? So, what will be the valid output when at least one of the input is 1 means valid output will be 1. D0 is 1, so obviously the output will be 0, 0. Now, D1 is 1. D1 is having higher priority than D0. So, whatever can be the D0 value, whether it is 0 or 1, least bothered about it. Now, D1 is having highest priority compared to D0, so we are not bothered about this D0, so we kept a don't care X sign. So, D1 is high means the output will be 0, 1. valid output will be 1 because at least one of the input is high. Now D2 is made as 1 in the next condition. D2 is having higher priority than D1 and D0. So whatever their values are, even if they are 1, 1, the priority will be given to D2, and according to this D2 the output will appear. So when D2 is high, the output is 1, 0. When D3 is high, the output is 1, 1. When D0 is high, the output is 0, 0. D1 high, 0, 1. D2 1, 0. D3 1, 1. And valid output in these 4 cases are 1 because at least one of the inputs are high. So when D3 is high and it is having the highest priority, even if they are made as 1, 1, what should be the output? Output will be based on D3, that is the output will be set to 1, 1. So D0, D1, D2 are made as don't care. We are least bothered about whether their value is 0 or 1, because when D3 is high means based on D3 value only the output is going to appear here. I hope this truth table is clear to all. Okay. If all the inputs are 0, in the first case you can clearly understand it. When all the inputs are 0, what is a valid output? It is 0, because this valid output is indicating that at least one input is 1. When all the inputs are 0, the valid output is 0. So when input is 0, is there any need of using the output? No need. So we kept it as don't care. So if all the inputs are 0, the valid output is set to 0 and y1, y0 are not used. So we are making it cross, and means we are not using it. Okay. So from here 0, 0, 0, 1, 1, 0, 1, 1. So here there are 4 inputs D0, D1, D2, D3. So how many possible combinations you can write for it? You can write total 16 possible combinations. So we have drawn here K map for it. For y1 we are having 3 outputs y1, y0, v. So first let us draw the K map for y1, then for y0, then for v. Now let us see how to simplify for y1. This truth table, it's clear for you, I hope. Okay, now when all the inputs are 0, the outputs are unused, so we have made them XX, don't care, and valid output is 0 because it indicates any one of the input is to be 1. And D3 is having the highest priority, D0 is having the lowest priority. D3 bit is having the highest priority, D0 bit is having the lowest priority. So this truth table where I have made cross, and instead of that I have elaborated this truth table because for 4 inputs we can write 2 to the power 4, that is total 16 combinations. So the elaborated truth table of priority encoder is given here. What it is explaining, let us see. So the inputs are D0, D1, D2, D3. These are the inputs and these are outputs y1, y0 and valid output. So for D0 to D3 the total 16 combinations I have written 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, double 0, 0, 1, 0, 1, 0, double 1, 0, 0, triple 1, 1 double 1 triple 0, 1 double 0 1, 1 0 1 0, 1 0 double 1, double 1 double 0, double 1 0 1, triple 1 0 and 4 ones. So this is how we write the truth table for 4-bit inputs. D0 to D3, that is the inputs is varying from 0 0 0 till 4 ones. Okay, so we have written the numbers from 0 to 15. So let us understand how to get these outputs. So what is V? Valid output. This will be set to 1 when any one of the input is high. So under first condition, when all the inputs are 0, the valid output is 0, and the outputs here y1 and y2 are unused, so they are don't care. Okay, so for all the inputs are 0, outputs are unused. Now let us see the next input 0 0 0 1. Here one of the input is 1, so valid output is 1. So this valid output will be 1 from 1 to 15, that is from 0 0 0 1 to 1 1 1 1, 4 ones. So this valid output will be 1 because at least one of the bit will be 1. Now D3 is high here. D3 is high means what will be the output here? 1 1. So when D0, for D0 the output will be 0 0. For D1 the output will be 0 1. For D2 the output will be 1 0. For D3 the output will be 1 1. So D3 is having the highest priority and D0 is having the lowest priority. So now when D3 is high, the output will be 1 1. Here D2 is high, the output will be 1 0. Here D2 and D3 both are high. So D3 is having the higher priority, so according to D3 the output will be coming as 1 1. Now coming to the fourth one, here D1 is high. D1 means what should be the output? 0 1. D1 is high, so it is 0 1. Here D1 and D3 are high, so D3 is having the highest priority, so what will be the output? 1 1. Now here D1, D2 both are high. D2 is having the highest priority compared to D1, so D2 is high means the output will be 1 0. Here D1, D2, D3 all three are 1, highest priority is D3. For D3 output, the output will be 1 1. Here D0 is high. D0 means output will be 0 0. Here the input D0 and D3 is high. D3 is having the highest priority. D3 is having the highest priority, D0 and D3. So the output will be 1 1. Here the inputs are D0 and D2 high. So D2 is high means output will be 1 0. Here the input high are D0, D2, D3. Highest priority is D3. So the output will be 1 1. Here D0, D1 are high. D1 is having the higher priority, so it will be 0 1. D0, D1, D3 are high. D3 is having the highest priority, so the output will be 1 1. D0, D1, D2, 3 are high. D2 is having the highest priority, so the output will be 1 0. When all the inputs are 1, D3 is having the highest priority, so accordingly the output will be 1 1, and the valid output is 1 because at least one of the input is 1. So likewise we have written this truth table. Now we have to solve 3 K maps, one for V1, Y1, Y0 and V. So before simplifying it using K map, let us find the list of minterms where Y1 is high. So Y1 is high at 1, 2, 3, 5, 6, 7, 9, 10, 11, 13, 14, 15. Okay, and we are having one X here, that is don't care condition. Don't care is at 0. So, which I have listed it here. So, y1 is equal to, where it is 1, 2, 3, 5, 6, 7, 9, 10, 11, 13, 14, 15 and 1 don't care is at 0. Likewise, I have listed for y0 where they are 1. So, list of minterms we could find. So, it is 1, 3, 4, 5, 7, 9, 11, 12, 13, 15 and 1 don't care is at 0. And the third output variable is v. This output variable is having 1 at these values. What they are? 1, 2, 3, 4, 5, 6, 7. If you see this valid output, all are set to 1 except at 0. So, for valid output, all the numbers are written except 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So, next step, after the truth table we have written the Boolean expressions. Now, based on this list of minterms and don't care, we will simplify the K-map. Now, let us see how to simplify the K-map. How many variable K-map we need to take? We need to take 4 variable K-map because inputs are D0, D1, D2, D3. So, first K-map will be for y1, other K-map for y0 and third will be for valid output. To generate this y1, we need to connect D2 and D3. Now, for connecting y0, for getting y0, we have taken the input from D3 and D1, D2 bar, D1, D2 bar are given to an AND gate. So, here we are getting D1, D2 bar and here D3 is coming. So, these two inputs are given to OR gate to get the expression D3 plus D1 plus D2 bar. Now, coming to valid output, we need to connect D0, D1, D2, D3. All the 4 inputs are given to OR gate to obtain the valid output. Okay. So, here we can draw the logic diagram in this way of y0, y1 and v. I hope the equations which you got are clear. Y0 we are having one octet and one quad, and here for v valid output we are having 4 octets, 1, 2, 3 and 4 octets are there. For 4 octets we are getting the valid output expression as D0, D1, D2, D3. Y0 expression is D3 plus D1, D2 bar. Y1 expression is D2 plus D3. So, based on the simplified K-map expressions, we have drawn this logic diagram. This is the logic diagram of priority encoder. So, what is a priority encoder? A priority encoder is includes the priority function. The data bits are assigned the priorities. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.